Okay, so we talked about probability models. We should know what those are now. We're going to keep using them. Now, thinking back to the insurance question that we've been talking about in the book, we know that the expected payout for each individual policy was $20. So that technically they're making like $30 on everybody, sort of, right? Based on the expected value. But you have to think about when we had data, we talked about the center, which is the expected value in this case. We also talked about how spread apart it is, right? If the center is $20, but the probabilities end up making that payout is really spread apart across people, then it's going to be kind of sketchy about how much they charge you for this insurance policy, right? Now, if it's like $20, it's pretty consistent. That's nice. But if it's like plus or minus like $1,000, that's a little more risky. So we need to know how spread apart this is too. So in this case, we have two measures, just like we did before. We've been using the mean for the center. So what goes with the mean? What measure of spread goes with the mean? What measure of spread goes with the mean? Standard deviation. So we're going to be using the standard deviation, but in this case, when we're finding it, if you're finding it by hand, which I'm going to show you how to do it first, then we'll do it on the calculator. You find the variance first, and then the variance, so you take the square root to get the standard deviation. Okay, so there's going to be a new vocabulary word, which will make more sense, I think, later on this week. But you're going to find the variance and then take the square root to get the standard deviation. Okay, so this was going to walk you through doing that with that insurance example. So again, it says no individual policy actually costs the company $20. We are dealing with random events, so some policyholders receive big payouts and others receive nothing. That's how insurance works. Because the insurance company must anticipate this variability, it needs to know the standard deviation of the random variable. So for data, we collect the standard deviation by first computing the deviations from the mean and squaring it. We did that like one time, then we did it in the calculator. And then we do that for random variables too. The variance is the expected value of all of those squared deviations. So you're going to square them and multiply them by the probabilities associated. And at the end, you get a number, and you take the square root, you get the standard deviation. So let's put that into practice. I'm going to show you an example. Here is your probability model from yesterday about the insurance. This should look familiar. So what they did is they found the deviations from the payouts with the expected value. All right, so you had x minus mu. So they took 10,000 minus 20, 5,000 minus 20, 0 minus 20. Everyone sees where that comes from. All right, those are the deviations from the mean. Then just like we did with data, you square them because you need them to be positive to do anything with them. We square lots of things in statistics. And then we find the variance by multiplying those squared amounts by the associated probabilities. All right, and that's going to give you the variance. The variance is just the standard deviation squared, though, so then you take the square root of that number. So here, for the insurance policy, the standard deviation is 386.78, $386.78. So it's not super, super spread apart. If you're thinking about that payouts are $10,000 to 0, depending on the insurance company, it might be too spread apart for them, and they might want to charge more. I'm going to do this with you one time by hand, and I'm going to show you how to do this in the calculator. You have two formulas. One of them is on the formula sheet, and one is not. We have the variance, which is sigma squared. If you see it as sigma squared, it makes more sense to get the standard deviation as sigma. You take the square root. Okay. The variance formula is on the AP statistics formula sheet. So if you need to do it by hand, you could. By the end of the year, because we're going to talk about this a lot more in a lot of other chapters, by the end of the year, if you don't know that the variance is just the square of the standard deviation, I haven't taught you anything. And so on the AP exam, you should be able to look at the variance formula and be like, oh yeah, I can do that, and then take the square root to get the standard deviation, if you had to do it by hand. Okay? So only one of them is on there. We're going to do this once by hand, and I'm going to show you how to do it in the calculator, and then all the other problems subsequently you can do in the calculator unless you just want to write them by hand. Up to you. Okay? So it says find the standard deviations of the random variables in exercise 1. Well, this is the table from exercise 1. I'm just going to do A. We did exercise 1 yesterday in class. I think we just did A. I think we just did A or just did B or something. So we need to know the expected value in order to do this, and the expected value was 19. Okay? So I'm going to find the standard deviation for this probability model. So here's what we do. We're going to find the variance first, and then we're going to take the square root at the end. So we take each outcome, we subtract the expected value, we square that, deviation from the mean, and we multiply by the associated probability. And then you add the next one. The next outcome is 20 minus 19 squared times 0.5. Plus 30 minus 19 squared times 0.2. So 10 minus 19 is negative 9. Negative 9 squared is 81. 20 minus 19 is 1, and 1 squared is 1. 30 minus 19 is 11. 11 squared is 121. That might make it easier to type it into your calculator. So the variance ends up being 49 when all is said and done. But it asked us in the question to find the standard deviation. So to find the standard deviation, we just take the square root. So the square root of 49 is 7. That's fine if you only have 3 outcomes. It's not a big deal. You're generally going to have to find the expected value before you find the standard deviation anyway. So it's generally you have all the information you need. But when you have more outcomes, you have 5 to 10 outcomes, I don't really want to do this by hand. It takes too long. So we're going to do the same question. We're going to do it in your calculator. So I can prove to you that this works. You need to go to, well, I need to clear that. You need to go to Stat Edit. Go to your list menu. You need to put your outcomes in the first list and the probabilities associated with them in the second list. Now, how did we find like mean and standard deviations before we were talking about probability? Stat calc, not 8. Stat calc 8 was for scatter plots. Yes, one variable stats, so we're still doing one variable statistics. But before we always let the frequency list and left that alone. But now we're going to need the frequency list. Generally, the frequency list is used because you have this list of data that has repetitions in it, and you don't want to type out 100 tens. So you would write 10 and then put 100 next to it so that it knows how many tens it has. In this case, we're using probability models. It works out the same. It does the same exact thing for us. It'll end up being multiplied and it'll all work out. So your frequency list is just where your probabilities are. So if by some chance you put the probabilities in list 1 and the outcomes in list 2, make sure your frequency list always is the probabilities. Okay? So we're going to calculate. And then we've got some stuff here. So, no, quit doing things. Interesting. Perfect. That actually worked out for the better. Okay, so here we have sigma x. Sigma stands for standard deviation. We just did this problem and it was 7, so that makes sense. Let's say they ask for the variance. They won't have the variance on here, but you just square it to get back to the variance. Okay? Yes. So from the variance, we take the square root to get the standard deviation. It works the same way. To find the variance from the standard deviation, you square it. It also lists your expected value on here. Okay? So that's on there for you. X bar, which in this case is really mu. Okay, so it's there for you. In my personal opinion, it's just as easy to do the expected value by writing it out or just typing it in your calculator. It's almost too much work to type it all in to the list and press the right buttons than it is just to multiply the outcome by its probability, right? But when it comes to standard deviations and variances where you're squaring things and subtracting and all this stuff, well, then maybe I want to use the table because it might take a little less time, okay? And you can do it by hand if you want to. Either way works. If you're on a free response question and they're asking you for something, in general, it would at least be nice to write down all of the work, and then you can put in your calculator and get the number if you wanted to. Show something you want to show something. Questions about finding the standard deviation? All right, then I'm going to give you an assignment. It's not that many questions. It's going to have some probability model stuff. Standard deviation stuff, that kind of thing. On number 10 is not actually a part A and B question. 10 asks you to find the standard deviation from exercise 2 from your homework last night. So I just want you to do B from exercise 2. You don't have to do both of them. It's the same thing over and over again, so I don't want you to do both. Okay?